palm oil industry is associated with the increment of carbon dioxide emission. Back in 2004, the Roundtable Sustainable Palm Oil along with decertification was established. The purpose is to ensure the sustainability of the palm oil industry. Does the certification affect the amount of carbon dioxide emission? Palm oil has been in our lives every day. For example, soap, cookies, as well as biofuel. These were made of crude palm oil or CPO, the derivative outputs of palm oil. The massive use of CPO in the world has led to the expansion of the industry. Figure 1 showed us that the size of oil palm area in Indonesia has increased significantly from 1 million hectares in 1990 to 14 million hectares in 2018. Since 2006, Indonesia has surpassed Malaysia in the palm oil production and contributes to 48% of total world palm oil production. Sadly, in some cases the expansion was done by burning the natural forest so that it can be used as a plantation. That activity might increase the amount of carbon dioxide emission, which is one of the components of GHG emissions. Here we can see that the carbon dioxide emission is one of the indicators for the Environmental Performance Index. Rspo was founded by the European Committee. It is a non-profit organization, aims to help maintaining the environment as well as the economic and social through the sustainable palm oil industry. The certification, which is voluntary, starts to adopted by Indonesia in 2008. Sherrill et al. 2019 examined the effect of global CPO price, marketing margins, and the size of palm oil plantation to the environmental destruction using Johannsen cointegration approach. They found that the global CPO price has positive impacts both on the short-term and long-term to the environmental quality index, while the size of palm oil plantations and marketing margins were negatively affect the environmental quality index. The amount of carbon dioxide emission was analyzed against the area used to produce CPO, CPO price of Indonesia, and the amount of CPO produced by Indonesia using EVIOS 10. The Rspo certification acts as a dummy variable in this study. VECM used for a variable that has cointegration amongst the other variables. The benefit is it can estimate the influencing factors in the short and long term. As we can see in the model, all of the variables are in natural logarithm except Rspo. Lane CO2 is the amount of carbon dioxide emission metric per capita. Lane area is the size of plantation to produce CPO in hectares. Lane price is the CPO price of Indonesia. Lane Pro is the amount of CPO produced by Indonesia. And Rspo is the dummy variable for the Rspo certification, which 0 belongs to the year before adoption and 1 belongs to the year after. The error correction term, or ECT coefficient, shows an adjustment of the dependent variable to return to long-term balance after a shock in the independent variable. ECT is valid if the sign is negative and the value is significant. There are 4 steps to do before we had our VECM estimation results. First, we did stationarity test using augmented leaky filler or ADF test at 0.05 alpha. VECM require variables that are stationary at the first difference level and avoid from the existence of a unit root. so that there will be no fake or spurious regression in the model. Table 1 shows that 4 out of 5 variables used in this study are not stationary in the zero level, thus need to be tested at the first difference level. The results are all the probabilities from variables tested at the first difference level are smaller than 0.05 alpha, meaning all of the variables are stationary at the first difference level. After all the variables are stationary at the first difference level, the optimum length of the lag needs to be determined. The lag length in this study was carried out using Akaike Information Criterion or AIC test criteria. Based on Table 3, AIC test criteria has the optimum lag at the third order, marked with asterisks. Third step is performing Johannsen cointegration test. The test aims to see whether there is a short-term and long-term balance relationship in the model. If the model used has at least one cointegration, then the VECM analysis can be performed. Based on the Table 4, the trace statistic both in trace and maximum eigenvalue test in the first hypothesis is greater than the 0.05 critical value, marked with asterisks. It means that there is one cointegrating equation and indicates the long-term and short-term balance in the model. Thus, VECM can be further conducted. Table 5 shows that this model have the R-squared valued at 0.5295. It means that 53% of the variation of dependent variable can be explained by the independent variables used in this model. Table 5 also shows that the F statistic is significant at 0.05 alpha. It can be interpreted that the amount of carbon dioxide emissions as the dependent variable can be explained by the independent variables simultaneously. The result of the VECM estimation can be interpreted as, in the long run, all variables in the previous period, which are the area used to produce CPO, CPO prices of Indonesia, and the amount of CPO produced by Indonesia, are associated with the amount of carbon dioxide emissions in Indonesia. While in the short run, two variables were associated with the amount of carbon dioxide emission, which are the area used to produce CPO and the amount of CPO produced by Indonesia. From the long-run equation, the area used to produce CPO will decrease the amount of carbon dioxide emission, as if the area used to produce CPO increases by 1 unit, then the amount of carbon dioxide emission will decrease by 1.88 units. Also, it will decrease by 1.46 units if there is 1 unit increasing from the CPO price of Indonesia. Otherwise, the increase of the amount of Indonesian CPO production by 1 unit will increase the amount of carbon dioxide emission by 1.5 units. Therefore, we can interpret from the short-run equation the coefficient value of the error correction term, or ECT, is negative and significant at 0.1 alpha. The negative value on the ECT coefficient indicates that after a shock to the independent variable, the amount of carbon dioxide emission will experience an adjustment of 0.7 units each period to return to its long-term equilibrium condition. Based on the data used in this study, the Rspo certification as the dummy variable is not associated with the amount of carbon dioxide emission by the t-statistics of -1.22364. It indicates that there is no difference to the amount of carbon dioxide emission before and after the Rspo certification was adopted in Indonesia. The findings is in contrary with what Brandy et al. 2015 has found. They said that the lower share of peat soils under certified palm oil and higher yields for certified FFB leading to the lower carbon dioxide emissions. This study also had been cited in the Rspo's page. Another study done by Carlson et al. 2017, he said that the Rspo impact on the sustainability concern in the oil palm sector may decrease if the Rspo memberships remain stagnant or not even increase by time. In this situation, it is likely to be more related with what has been mentioned before by Carlson et al. 2017. This because the study uses Rspo as the dummy variable in order to knowing the difference between the period before and after the adoption. From this study, we can conclude that the model has both short and long-term equilibrium relationships, and the Rspo certification is not associated with the amount of carbon dioxide emission. So, does Rspo certification affect the amount of carbon dioxide emissions? My name is Yahya Safiuddin Hilmi and Ms. Arini Wahyutami as the co-author. To all of the committee, presentators, and audiences, thank you very much.